Assalamualaikum and hi everyone. My name is Vanu Bazri binti Badrun Ishaq. I'm first year student from Science with Educational Program with major in Physics.
And hi, my name is Yohana Anissa binti Suhandi Al-Azhar. I am year 1 student from Science Educational Studies Program and major in Physics.
Hi, my name is Akmal Hafizi bin Anwar, first year students of Engineering Physics Program from School of Physics.
Have you ever wondered how your phone managed to know which direction you're holding? Well, right here, we are going to solve all your curiosity. Built in this phone is a tiny device that can detect changes in orientation and tells the screen to rotate. The device is called an accelerometer. It measures acceleration of movement. But how is the piece of an electronic sense something mechanical like acceleration? Well, the answer is MEMS, Micro Electromechanical System. Cool, right? So, let's tell you more about accelerometer and MEMS.
Hi, I'm Yohana and today I will explain to you about the function of accelerometer in our smartphones. So basically, the accelerometer is a device that used to detect the orientation and tell the screen to rotate. Besides, the gyroscope or gyro is a sensor that present in our smartphones to help the accelerometer out with understanding in which way our phone is rotating. Accelerometer is a device that used to measure a linear acceleration in a movement, which is the rate of change in velocity. Besides, the gyroscope or gyro is the sensor that used to sense the angular rotational velocity. Now, we know that both sensors measure the rate of change for different things. That means the accelerometer will able to measure the directional movement of a device but not able to measure its lateral orientation. That's why a gyroscope required to fill that info. So, the combination between the 3 axes of accelerometer with 3 axes of gyroscope, it will produce an output that is clean and responsive. Okay, now let us see how it works.
Okay, so now let's take a look at the fundamental concept of an accelerometer. Consider a spring mass system. So here we have a body of mass m is attached to a spring of spring coefficient k. So when a force is applied to the body, it is displaced in the direction of the force with displacement x and acceleration a. So by solving the Newton's law, we get the force F equals to ma and the F as equals to kx. We then equate the forces and we get the ma equals to kx. From here, it is obtained that the acceleration is a function of displacement, that is, a equals to fx. This implies that for any given information of the displacement, we can then compute for the acceleration of the body. A bit of new information regarding the device being discussed. An accelerometer uses a method called the capacitive technique for the computation of the phone's orientation. Now, from the equation of capacitance, C equals to epsilon A over D, where D is the distance between the two plates of the capacitor, the idea goes in such a way that by varying the distance between the two plates D, this will also change the capacitance C, such that when the D decreases, the C increases and vice versa. Now, we have a modified spring mass system where a capacitor is attached to it. It is important to note that in this comp finger arrangement, the plate attached to the mass is movable and the other is stationary. So when the mass accelerates due to the gravitational force, it causes a change in the displacement. As a result, the capacitance across the plates also changes due to this changing displacement. So basically, the IC in smartphones computes the capacitance C, and then the value of the displacement can be computed. Lastly, from the function A equals to fx, the value of the acceleration can eventually be determined. So there we have it. This is the underlying principle of measuring the value of acceleration in the computation of the accelerometer. So, what are the advantages of MEMS? One of them is it transforms traditional bulky mechanical systems into miniature ones, thus permitting more flexibility than ever. Secondly, it has, without a doubt, a better functional performance and it is mass producible. Not least, it does also have applications in high sensitive sensors, actuators, and in most industrial systems in general. The only predominant disadvantage of MEMS is the cost. The upfront setup costs for the fabrication facilities are very expensive. This includes the testing and the quality control stages alongside with the appreciably high fabrication cost per unit quantity. Now, let's recap what we have just learned. The screen orientation features of a smartphone are the technology of an accelerometer, and an accelerometer is a MEMS, the electromechanical system. By definition, MEMS is a wide range of microfabrication designs and mechanisms that involves realizing moving mechanical parts at the microscopic level. And that concludes our topic today, the accelerometer in smartphones. This is Group 13 signing off. Thank you.